Ever get that like sinking feeling when your phone dies and you really need it? It's like the more our devices can do, the faster the battery just disappears. Turns out there's a reason for that. We're hitting the limits of what traditional microelectronics can handle. But there's good news. The future of computing is actually looking pretty bright, thanks to some, get this, brain-inspired approaches. Think about it. Our brains are super powerful and efficient. Like they can process tons of info while using less energy than a light bulb. So scientists are kind of taking a cue from nature, developing microelectronic designs that work more like how our brains do. Instead of everything flat on a chip, we're building things vertically, like a high-rise building. It lets us pack in way more processing power, but in a smaller space, and the data doesn't have to travel so far. But it's not just about making things smaller and faster, it's about smarter too. And that's where in-sensor processing comes in. Imagine a camera that can analyze the images it takes right there on the sensor. No need to send all that data to a separate processor. Saves energy and allows for real-time decisions. Think self-driving cars or those smart security systems. And on the topic of energy efficiency, there are huge advances happening with the materials we use in microelectronics. Scientists are looking at materials that use way less power, which means our batteries could last so much longer. And get this, they're also working on materials that can handle extreme conditions like space or the deep ocean. Imagine sending a probe to the bottom of the ocean with electronics that can deal with the pressure and freezing temps. And this isn't just about cool gadgets. It could totally change industries like healthcare, transportation, even energy production and science. So how do these brain-inspired designs actually work? Well, let's dive a little deeper. Okay, so to really get how big of a deal these brain-inspired designs are, let's compare them to like how our computers work now. Imagine a city, right? And the CPU, that's like City Hall, making all the decisions. You've also got memory chips. Those are like giant libraries holding info. But for anything to actually happen, data has to go back and forth between City Hall and the libraries. It's like constant traffic jams, uses a ton of energy. Now our brains, they're way more efficient. The processing and store happen much closer together. It's like each neighborhood in our city have its own little city hall and library, so most things are handled right there locally. That's what we're going for with these brain-inspired microelectronics, that localize efficiency. We talked about 3D stacking before, but it's worth saying again how important it is here. Building things vertically, like that high-rise, it's not just about fitting more in, it also dramatically cuts down on how far data needs to travel. So things are smaller, but they also use less power. Win-win, but we're not just shrinking things, we're making them smarter too. Remember in sensor processing, instead of sending all that raw data from a sensor to the main processor, we're giving the sensor some brains of their own. So like in a self-driving car, instead of sending every bit of visual data to a central computer to make sense of, the car can make decisions right there on the spot based on what the sensors are seeing. Quicker reactions, better use of resources, even the ability for the system to learn and adapt as it goes. This is especially huge in fields like scientific research, where you have mountains of data coming in. Think about a telescope that can filter out all the useless stuff in real time and just focus on the important data, or a medical device that can instantly pick up on tiny changes in a patient's vitals, maybe even save their life. And as AI gets more and more advanced, these improvements in microelectronics become even more crucial. AI algorithms, especially for machine learning, need a ton of processing power. But with brain-inspired designs, we could build AI systems that are super powerful, but also really energy efficient. So what does this mean for us in our daily lives? Think about smartphones that last for days on a single charge. Laptops that can handle anything you throw at them without the fans going crazy. And AI systems that can help solve some of the world's biggest problems, all while being mindful of their environmental impact. And you know what else is really cool? These new materials open up so many possibilities for using electronics in places where they just couldn't survive before. Like, imagine trying to send something to the bottom of the ocean, all that pressure, the freezing temperatures, or how about space exploration, or even close to a nuclear reactor, all that radiation. We need tough, reliable tech that can handle that. That's where the advances in materials science are really making a difference. Sensors that can survive a volcano erupting, or rovers that can handle the surface of Mars. It's like we can go anywhere and explore anything now, gather data from the most extreme places in the universe. And we can't forget about quantum computing, which is a whole other level of complexity. Those quantum computers are super sensitive. They need just the right conditions to work properly. All the things we've talked about, the 3D stacking, the new materials, those are going to be essential for building the infrastructure that quantum computing needs to really take off. So yeah, the future of microelectronics is pretty amazing, huh? By taking inspiration from how our own brains work, and by pushing the limits of what materials can do, it's not just about making our gadgets a little bit better. It's about creating a whole new world of possibilities. It's a reminder that sometimes the best ideas come from the most unexpected places. And by embracing these advancements, we can create technology that's powerful and capable, but also works in harmony with our world. Who knows what we'll be able to achieve?